In this video, we are looking at pulleys. So here we've got a situation where we've got two particles, A and B, of mass 2 kilograms and 3 kilograms. They're connected by a light, inextensible string again. So it's a string, it's light, that means it's got no weight. It's inextensible, which means the acceleration of A and the acceleration of B will be the same. And it's going over a smooth, fixed pulley. So it's smooth. What smooth means is it means the tension on both sides is the same. So there's no kind of frictional force, there's no resistance in the pulley. The tension on one side of the string and the other side of the string is exactly the same. So the particles are released from rest with the string taut, and we need to work out the tension and the acceleration. So firstly, I'm going to draw on the forces. So on B is going to accelerate downwards because it's heavier than A. So the force is 3G, that's the weight of B, and it's going to be resisted by a tension. And I'm going to draw another tension as well, just to show that there's an equal and opposite force. The string is going to weigh down on the pulley, and the pulley is going to give an equal and opposite force back. And the weight of A is 2G. It's going to be resisted by the tension in the string, and there's also an equal and opposite force from the pulley. So the forces acting on B are the 3G and the T. The forces acting on A are the 2G and the T. And acting on the pulley, we've got 2T. We need to find the tension in the string. So we're going to use our equations of motion, our F equals ma. And let's do one equation for A and one equation for B. I'll start with B. B is going to be moving down. So the forces is going to be 3G take away T. And that's equal to mass 3 times acceleration. Same thing for A. A is going to move up, going to accelerate up. So the forces for A are T minus 2G equals mass times acceleration 2A. So I've got two equations with two unknowns. Remember, G is a constant, it's not an unknown. And we're going to solve them simultaneously. You can just type this into the calculator, can you? If you rearrange it, you could just type it into the calculator. But if we add the two equations, so for the right side, 3A and 2A make 5A. For the left side, 3G plus minus 2G is just G, and minus T plus T is nothing. So if we add both sides, we get G equals 5A, so A must be 1/5 of G, and that's acceleration meters per second per second. If we want to find tension, we can substitute A back in. So if I substitute A back in, I'll get T minus 2G equals 2A, which would be 2 times 1/5 of G, which is 2/5 of G. Add 2G to both sides. So 2/5 G plus 2G. 2/5 plus 2 will be 12/5. So it's 12/5 of G, and tension is measured in newtons. One for you to try. See if you can give it a go. So firstly, draw the forces on. So the weight of A is 4G, and it's going to be resisted by a tension force. The weight of B is 3G, and it's going to be resisted by a tension force. And there's also going to be two tension forces acting down on the pulley. So if we look at an equation of motion for A is going to accelerate down because it's the heavier one. 4G take away T equals 4A. Equation of motion for B, T minus 3G equals 3A. and add the two equations together, which will eliminate t. Minus t plus t is nothing. So add them together, we get g equals 7a. A must be 1/7 of g meters per second squared. Substitute a back in. So let's have t minus 3g equals, so 3 times a will be 3/7 of g. So t is going to be 3g plus 3/7 of g. 3 is 21/7. 21/7 and 3/7 will be 24/7. And that's in newtons. Here's another question. Two particles A and B of masses 2 kilograms and 3 kilograms, respectively. So A is got a weight of 2g, mass times gravity. B has a weight of 3g. They're both going to have a tension force acting on them. So B is going to be resisted by the tension. A is going to be pulled along by that tension. And of course, there's an equal and opposite force acting on the pulley. And so it's a smooth horizontal table. So again, they're connected by a light inextensible string. So acceleration for both of them will be the same. It's a smooth table. So no friction force, nothing resisting A. And it's a smooth pulley. So tension on both sides is the same. The string is taut, it's released from rest. Find acceleration and tension. So again, let's do an equation of motion for A, equation of motion for B, and find A and T. So for A, tension is the only force, so tension is the resultant force, there's nothing resisting it, equals mass, which is 2, times acceleration. And for B, we have 3g minus t equals 3 times acceleration. Add these two together. I'll write that one under that one. So add them together, we get 3g equals 5a. So A is 3/5 of g meters per second squared. And t is equal to 2 times A. So t is 2 lots of 3/5 g. That's 6/5 g. And it's measured in newtons. One for you to try. Give this one a go. So let's draw on the forces. We've got A is 1.5 kilograms. So its weight is 1.5 g. I probably should have put the normal reaction on. Let's put 1.5 g there as well. 2g over here. B has got a mass of 2 kilograms, which means its weight is 2g. There's a tension pulling A along. There's a tension resisting B. And acting on the pulley, the two equal and opposite tensions. So they are our forces. Let's write an equation of motion for A and B. So for A, it's T. There's no force resisting it. So T is the resultant force, and that's equal to mass times acceleration. For B, we've got 2g take away T. They're the forces acting on it, and that's equal to 2 times acceleration. Add the two equations together, we get 2g equals 3.5a. So acceleration is 2 over 3.5 g, or 4/7 of g. Meters per second per second. T is 1.5a, so 1.5 times 4/7, it'll be 6/7 g newtons.